What up, math heads? Today we'll be continuing our discussion on factoring polynomials, specifically factoring trinomials. Tri meaning three, nomials meaning terms, so three terms. And so a general trinomial is in this form, ax squared plus bx plus c, where a, b, and c are just numbers, x being our variable. Generally, the method I'll show you here will help you solve and factor any trinomial that you can actually factor by hand. We'll learn some techniques later on that will help you solve any polynomial or trinomial, excuse me. But for now, we're just going to be factoring, so this method will do you well. So what are we looking for here? Well, let's give an example here. Let me use different numbers here. Okay, so let us say we have this polynomial and we want to factor it. Now, our old method was finding the greatest common factor and pulling that out in front, right? But you can see that here we don't really have any common factors. This is an x and an x, this is a 7 and an x, and this is a 6, right? So we don't have anything that's in common between any of these guys, so that method isn't going to work. So there's this method, sometimes referred to as the AC method. If you notice here, the numbers in front of these terms are actually a, b, and c. So for the first term here, we don't see anything, but when we don't see anything, multiplicatively, we mean 1, right? So what we're looking for is two numbers, p and q, okay, where p times q is equal to a times c, and p plus q is equal to b. So what do we mean? We just need two numbers that multiply to 1 times 6 and add to 7. So we need PQ 1 times 6, which is just 6. So two numbers that multiply to 6. And those same two numbers should add and equal 7. Okay? And so what you want to do is you want to start out with the 6 and try to figure out factors of it. So what numbers multiply to 6? Well, we have 2 and 3, right? And you don't have to do them in like 3 times 2. As long as you have one of the pairs, it's the same thing. And the only other factors of 6 are 6 and 1. So both of these multiply to 6, but we need to check which of these two factors add to 7. And you'll see that 2 plus 3 is 5, so this isn't going to be the pair we want. But 6 plus 1 is 7, so this is the pair we want. And so what we do is, you may see someone use a method like this, where they put a times c up here and b over here, and essentially it's the same idea here, just written a little differently, right? We need a number that multiplies to 6 and adds to 7, and then you put the numbers that you get over here. So here we have 6 and 1, just showing you two different ways of showing your work here. And so what you're going to do is this 6 and this 1 are actually 6x and 1x, and we're going to break this 7 into those two terms. So we have 1x squared plus 6x plus 1x plus 6. And if we added these two terms together, we would just end up right there. Okay, so why are we doing this? Well, because here we only have 3 terms. What we want to do is end up with an even number of terms, specifically 4. And why is that? Well, this method is called factor by grouping. Okay, and so for us to be able to group things, we need an even number of terms. So we have the 1x squared plus 6x plus 1 x plus 6, and so essentially all we're doing is we're wrapping the last two terms in parentheses and the first two terms in parentheses. And now we're doing what we did last section. Once we end up with 4 terms, we are looking for the greatest common factor of each of the parentheses. So this term, right, this is x times 1. The second term is 6 times x, right? Okay. Then we have the plus. What is the first term? Well, it's 1 times x. What's the second term? Just 6, right? And you could always write times 1 if you wanted to, but it's not really necessary in most cases. So what terms do these two have in common? These two terms right here multiplicatively. Well, they both have an x, but that's all they have in common. So what we can do is factor out the x, and what's left on the inside? Well, we took one of the x's out, right? And so what's left on the inside? It's just an x. And then we have a plus, and what's left here? Well, that's just a 6. Cool. Now let's look at this term. Is there anything that we can factor out here? Well, they don't seem to have any terms in common. So when there's nothing in common, all you can factor out is a 1, and so that's what you'll do. You just factor out a 1, and so these terms basically stay the same, right? What you notice now is that these two parentheses are exactly the same. So what you're thinking of is this is one big parenthesis, and this is one big parenthesis. I'm using brackets here to differentiate. And what you're doing is you're going to factor out the binomial. You're going to factor out this whole term because you have one here and you also have one here. So we'll factor that out. And what do we have left in the first spot? Well, we have an x here. And what do we have here? Just a 1. Okay? And you'll see that if you were to multiply these, use the rainbow method, x times x is x squared, x times 1 is x, 6 times x is 6x, 6 times 1 is 6, and you'll see that you end up where we started. And so this factor by grouping thing essentially is a method to help you factor trinomials. Okay, so this becomes our factored form. Now, you'll know if you messed up when doing this method if you don't end up with matching terms here. You need your binomials to match. If they don't match, that means you goofed up somewhere. All right, so let's go ahead and try a different one. So assume we want to factor this term out. Okay, and before we move on here, let me scroll back up really quick and make a comment here. Notice that when we started this problem, it started with x squared plus 7x plus 6. And then we found the p and q that worked were 1 and 6. When this is a 1, once you find out what these two terms are, all you have to write is x plus 1, x plus 6, and you're done. And so you don't have to go through all of this factor by grouping nonsense if and only if this term is 1. So if there's another number in front of the x squared, you can't just write the p and q. Alright, so this is only a shortcut if this number is 1. Alright, so in this case, you'll see that this number here is 2, so we're not going to be able to use that shortcut here. And so once again, we're looking for two numbers, p and q, that when multiplied give us a times c, and when we add p and q together, they give us b. So we're looking for p times q to equal a, which, so I'll write it above here, ax squared plus bx plus c, goes in alphabetical order. AC here, a is 2, right? And c is 5. So we're looking for two numbers that multiply to 10, but add to 11. And so we take 10, we look at the factors of 10, and so what numbers multiply to 10? Well, 5 and 2 do. Okay, is there anything else? No, that's basically it because 5 and 2 are both prime, but we also have the trivial one, which is 1 in itself, right? 1 and 10. Do either of these add up to 11? Because that's what we're looking for, right? Both of these multiply to 10. Which one of these adds up to 11, right? And it's this pair right here. So we're going to do that same thing. We're going to take 11x and we're going to separate it. And so I'll do the AC thing here again. A times C is 10. B is 11. We're looking for two numbers that multiply here and add to 11. And so we get 10 and 1. So 10x and 1x. And we're going to replace the 11x with both of these two terms added together. Why do we do that? We do that because we're trying to change these 3 terms to 4 terms so that we can group them. Remember, this method is called factor by grouping. So we need an even number of terms so we can group stuff. So we're going to group this like this and that like that. And we're going to look in here and we're going to say, what do these two terms, what's the greatest common factor between these two terms? Well, this one has 1x and this one has 1x. Okay, so we know there's an x that's a common between these two guys. Well, what else is there in common? Is there a number multiplicatively that's in common? Yeah, there is, because 10 is 5 times 2, right? And so there's a 2 here and a 2 here. So we're going to factor out not just x, but we're going to factor out 2x. And so now we need to write what is left over. Well, 2x times what gives me 2x squared? Well, just an x, right? That's what was left over. We haven't factored that out. And what did we not factor out of here? Well, remember we had 2 times 5 times x. And so if we put a 5 here and we multiply, you'll see we'll get the 10x there. So that's what's left over. Cool. And what does 1x and 11 have in common? Well, remember 11 is prime, so the only thing that multiplies to 11 is 1 and 11. Excuse me. And so there's not really going to be much to factor out, and so there's nothing to factor out in between these two terms, because this one doesn't have an x and this one doesn't have an 11. So when there's nothing to factor out, we always just factor out a 1. Okay? And so what's left over here? Well, the whole thing is, because 1 times anything is itself. And so do these terms match? They don't, right? So we must have goofed somewhere. So let me see if I can find where I done goofed. Oh, that's why. Because this term is not an 11, it's a 5. Right? We're bringing down the third term. Cool. So it's 2x squared plus 11x plus 5, and so we broke the 11x down into 10x and 1x. So 10x plus 1x, and the 5 just comes down, and so still here, 5 is prime. It's 5 times 1, and so since we can't factor out anything from here, we're just going to factor out a 1, and everything in the second term just stays the same. And so now they do match, okay? So that's how you figure out if you've made a mistake like I did. So you'll see here again, right? If we wrap these in brackets, this term has an x plus 5 being multiplied, and so does this one. So that's the term that we can factor out. We're going to factor out an x plus 5. And what's left in this one? Well, we have a 2x here. And what's left over here? Well, just that 1, right? And so now this is what we got as factoring this trinomial into two binomials. And all we have to do to check is just multiply it back in. So x plus 5, 2x plus 1. X times 2x is 2x squared. X times 1 is x. 5 times 2x is 10x. 5 times 1 is 5. And so if we add the like terms together, x plus x is 11x. There's no other like terms. And so is this what we started with? Yep. It's right here. And so this is our factored form. This would be our solution right here. Okay? So we'll cut the video there, and we'll have a couple special cases in the next video. See you next time.